Hello everyone. So we are going to talk about isochoric transformations. So we are going to go from state 1 to state 2, considering this time that the pressure is constant. How to calculate the work and how to calculate the heat in this situation. For the heat, it's going to be this expression that you have to use. So Cp delta T. The variation delta T is always the final temperature of this transformation minus the initial temperature of this transformation. So we have T1 here, T2 at the final state, which means that the variation is going to be T2 minus T1. So that's it for the heat. Now for the work, how to calculate the work. We are going to use the very general formula. We are going to start from the fact that the work is the integration of minus P dV. Because as you remember, the elementary work dW is minus P dV. So then if you are doing the integration, you need to keep the elementary scale inside of your integration. So then when you do that, you can see that the fact that the pressure is constant, so the P can just get out of the integration, as it's a constant in this specific case. Something interesting. What do you think are the boundaries in this integration? So I'm going to let you the time that I write the next things of this equation for you to think about the boundaries before I tell the answer. Okay, so the boundaries are 1 and 2. So basically, if you have an integration, you need to specify from where to where you are doing your integration. You can just indicate brackets in the beginning that specify the state that you are considering. But after, in the next step, you have to specify what is the variable that you are considering in the boundaries. Because when you are doing an integration, it's depending on g of something. And this something is the physical quantity that you are integrating here. So in this example, we will have to tell that the boundaries are going to be V1 and V2. So it's going to be minus P integration V1 V2 dV, like that. So once we do that, we just need to make the very simple process of integration. Here we have nothing, so it's just going to be the variable itself as the primitive of the integration. So we'll have this result, V2 minus V1, like this. And it means that at the end of the day, you have minus P delta V as the work for the isobaric transformations. Some notes that you can have also is the fact that in this case of isobaric transformations, the heat is equal to delta H, the enthalpy variation, which is also equal to gamma delta U.